Change and Energy of the League of Women Voters of Delaware. Delighted that you could be with us today as we explore the possibilities of an offshore wind project for Delaware. Excuse me. The League is a nonpartisan political organization dedicated to the belief that democratic government depends upon informed and active participation in government. As some of you old timers may remember, the League traditionally has a special day in Dover in early spring devoted to current issues and an opportunity to speak with legislators. So this year we're having several days. Is Delaware ready to move in the direction of an offshore wind project? How important is it that a large portion of our electricity come from renewables? After hearing the presentations today, we think you may agree that the time has come to consider an offshore wind project for Delaware. Toward that end, we'd like to invite our League Days in Dover participants to support a concurrent resolution to engage the Special Initiative on Offshore Wind, or SIOW, to prepare a scientific study that would lay out the choices we'll need to make before signing an offshore wind contract. It's important to understand that although an SIOW study would cost nothing to the state of Delaware, since it's philanthropically funded, it would involve a large commitment on the part of this group. The Special Initiative on Offshore Wind is understandably not eager to expend the effort to work on a paper of this magnitude that no one will read. A legislative resolution will assure the SIOW that not only does the legislature want such a study, but that once it is completed, that it will be read and acted upon, either up or down. Now, before we begin, a few comments on our operations. This session is being recorded and can be seen later on the LWVDE website. Our virtual audience is on mute. If you wish to ask a question or make a comment, you may do so in the chat box. When asking a question, you may preface the question with the name of the speaker from whom you would like a response. The chat box will be monitored by League member Dick Johnson, who will also introduce our speakers. Following all three 20-minute presentations, Dick will take questions and moderate the discussion. Dick? Are you there, Dick?
Oh, yes, I'm here. Thank you very much, Peggy. I'm really excited about this. We have three wonderful speakers, and if you didn't know anything about offshore wind by the time we're through here, you certainly will. I think you'll find it very educational. And as Peggy said, if you have questions, we will address those questions at the end of the session. My plan is to go through and introduce a brief introduction of each speaker just prior to their presentation, and we'll start. So the first person I'd really like to introduce is a good friend of mine too. Dr. Willa Kempton is a professor in the College of Earth, Ocean, and Environment, and in the Department of Electrical and Computer Engineering at the University of Delaware. He is a co-founder and associate director of the Center for Research in Wind, and he is an affiliate professor at the Danish Technical University. He has also led groundbreaking analysis and policy recommendations on the cost of offshore wind power and on new deployment methods for offshore wind turbines. Dr. Kempton directs about 10 professional researchers and graduate students in research on clean energy technology. He lectures widely and publishes scientific and technical articles on offshore wind power, electric transportation, and energy analysis. Dr. Kempton created the concept of using electric vehicles to provide grid services and has 4 patents for the technology integrating electric vehicles with the power grid. He has also led the groundbreaking analysis and policy recommendations on the cost of offshore wind and on new deployment methods for offshore wind turbines. So without further ado, Dr. Kempton, I'll go the other direction. There we go.
Thank you very much, Dick. I appreciate it. We are, when I first started talking about offshore wind, and some of you heard this, before 2010, it was an idea, and now it's a lot of contracts and actually 8 turbines running, I guess, which are demonstration projects. This table shows where we were actually a year and a half ago, and it keeps getting updated. I haven't updated it yet, but just to give a sense of scale, 1 gigawatt GW is the size of a nuclear power plant or a large coal generator. And so these numbers are gigawatts. A gigawatt offshore wind facility is about a $2 to $3 billion investment by investors who think they can put in the money and then sell electricity. And Delaware, for scale, runs on average about 1.3 gigawatts. So gigawatts about, what Delaware needs to run. So to run Delaware and offshore wind, you need about twice as much because it doesn't blow steadily all the time. But so you might have 2 or 3 gigawatts if you want to totally run Delaware from offshore wind, but that's not what we're proposing. We would look at, how much would make sense to put in if we do a more thorough study on this. So this just shows the states. One state you notice missing there is Delaware. And believe it or not, every state, Delaware was one of the first out of the starting gate here with a proposal that didn't get built. But right now, every state from Massachusetts to Virginia has a contract or a state law requiring offshore wind to be provided to the state, except Delaware. We're the only one that's not doing this right now. It doesn't mean it's a good idea, but it's just that we're not making the same decision that all of our neighboring coastal states are. Next slide, please. So graphic, map on the map, these are areas that are designated by the Federal Department of Interior. Within that, the Bureau of Ocean Energy Management, BOEM, which has just gotten a new director. I had a conversation with her on Monday. So they designate space that's allowed to be used for building offshore wind turbines after environmental and alternate uses, shipping and so forth analysis. And then it's up to states to decide whether or not they want to buy power. So this is the leasing of area that's allowed to be used. And that's all federal. Then the next step is, do we want to use those spaces? And there's a space designated already off Delaware, and there's one off New Jersey and off Maryland that could be used. So this is just showing you the extent of the leases so far. So next slide, please. That's what a offshore wind project looks like. Turbines in the ocean. I won't get into much more detail here, but if you look at the little box at the top of the tower and at the center of the 3-blade rotor, it looks like a little box there. You can just see it in this photograph. But if we look at that box blown up on a modern turbine, these are a little bit older in this picture. Next slide, please. It's actually quite large. If you look down in the background on the left and also near the doorway on the right, you see people for scale. So this is a 12 megawatt turbine. I actually saw this thing being manufactured. This is in Saint-Nazaire on the west coast of France. It's amazingly large when you're in the same factory with it. This is a 12 to 13 megawatt turbine, which would power about 4,000 Delaware houses. So one unit, 4,000 houses. If we were building, say, an 800 megawatt project or just under a gigawatt, it's kind of a standard size right now, that would be 67 turbines this size. just to give a sense of the scale and quantities. Next slide, please. So how can Delaware participate in this market? I think we could do it in a little bit more clever way based on experience from our neighbors, but we can also look at them. Some have done it in a way that produces higher cost electricity, and others have done it in a way that produces quite low cost electricity. So we can learn from that. But there's 3 steps: craft a power solicitation for the utilities to use. And that involves a lot of skill and using experience, as I said. So we want to be thoughtful about that. Second step is the Delaware plus 1 or more utility, that is the state plus 1 or more utilities, would evaluate bids that come from developers and pick the most favorable. And if we don't like any of them, we don't have to pick them. So when you decide to do a solicitation, you're not required to buy the product. That would be the second step. And then once that's starting to move, if there is a bid that gets picked by the utilities in the state, then we would solicit facilities to locate in Delaware. Those can be tied to the contract or not tied to the contract, but that's actual manufacturing ports, operations and maintenance centers, maybe educational or testing facilities. Those would be becoming more part of industry, and participating in a power contract is part of that process. So let's look at a little more detail on each of these 3. Next slide, please. So to craft a power solicitation, like I said, we want to ensure the price is reasonable. Maybe set an upper limit on the price, for example, or it's not a qualifying bid. There are other ways to do it. Second is this, just for clarity, the state is not building a project. The state is not investing, and the state itself is not buying power. The state sets up a framework, like it always does, for the utilities to operate. The state, through the Public Utility Commission, regulates the utilities. They are monopoly operations because the power lines only go from one company to your house. So that's regulated by the state in the same way the state would regulate this, but the state would not be transacting power or not even necessarily subsidies. It would be determining the rules of bidding and accepting bids and purchasing power. The developer is the one that builds the project, gets the investment, does all the technical work, takes the risk if something doesn't work, and then ultimately sells power to the utility. So the second phase, Delaware plus the state plus 1 or more utilities evaluates the bids, picks the most favorable. This is a multi-year process. After there's already a solicitation, it might take 3 to 4 years to, once there's a bid accepted, to prepare. It's a $2.5 billion project to use the sort of standard size. So you've got to order a lot of parts, and then you have to plan. You're the developer now. You have to plan how you're going to manufacture it, get the boats lined up, get the ports lined up, and this requires manufacturing. It requires a lot of industrial facilities. Some things might be made in Europe, but we've got now a size of a market, as you saw from that first slide. We're looking at $100 billion of expenditures in the Northeast here over the next decade or decade and a half. So a lot of those parts will require making factories locally. Europe couldn't even supply all that we're doing in the US right now. We'll supply some things, I'm sure, but so there's all of that, all of those facilities. Then that's the solicitation of facilities, like I was saying. Not necessarily linked to the power bid. If we could link it, that'll be kinds of options that need to be studied. Can be linked. It might increase the price of electricity if you do that. Or you can let the market decide. I think that Delaware has some really great locations for a port. I'll talk a little bit more about that, which is actually better than any other neighboring states. But it's hard for companies to participate in that when we're not participating in the market. Next slide, please. So what type of facilities are we talking about? I mentioned a couple. Operations and maintenance. You need only 5-acre port. We've got several places in Delaware this could be. You typically want it closer to the wind farm. Creates 30 immediate jobs right at the facility, about 100 induced jobs. And those are jobs that go for 25 years. So actually in job years, it can have more than the deployment itself, although you have a lot more people involved for a couple of years for deploying it. Training, other type of facility I mentioned, manufacturing and assembly, and I'll show an example. New Jersey's already building manufacturing facilities for offshore wind, and then marshaling ports where you put everything together and then you go out to build the turbines, which is, I'll give you a little bit more detail on that also. So next slide. So this is from yesterday's Philadelphia Inquirer. And the people that you see are in Paulsboro, New Jersey, working right now while we're talking and sitting in our study and so forth. So this is not hypothetical. This is going on in neighboring states. People are building things to be able to deploy all these required, contracts and state mandates for building offshore wind. The factory in Paulsboro, if you look at the diagram of the wind turbines on the right in this diagram, also from the Philadelphia Inquirer, you can see the turbine again, then the cell at the top, that box at the top of the tower, and then under the yellow, that gray piling that goes down into the ocean bottom is called the monopile, and that it's a very heavy piece of steel. It's about 6 meters in diameter, about 20 feet, and 5 inches thick steel. So that's what they're building on the left. They're building facilities for getting steel plate into New Jersey, into Paulsboro, rolling it, welding it together to make a monopile, and then shipping it out. That's the dock they're building. So you need a lot of rebar and concrete to load out a multi-100-ton structure onto a ship. So that's what they're doing. So that's just one part. You can see, the yellow thing, the transition piece, it's called, the tower above water, the nacelle we saw earlier, the blades, all of these things have to be manufactured. So just to get a sense, it's really a short drive for most of us here online to see that port under construction. Next slide, please. Another example is a marshaling port. This is something we've studied and done a study at the University of Delaware, actually, to see potential marshaling ports. And again, New Jersey is planning and is fairly far along on a marshaling port. But when we look at the number of projects that are being built, it's not nearly enough. So that doesn't, just because New Jersey is first off the line, also on the marshaling part, that doesn't mean we can't do it. We have a very good location. And as you can see from this diagram, to typical distances from the marshaling port to the project that's being built in the ocean, the green half circles show plausible sort of distance that you would go as part of a construction project. We could cover from the Delaware Bay with the New Jersey site plus the potential Delaware site could cover most of the projects that are now planned. The New Jersey one is in Salem, by the way, just north of the reactor complex. So it doesn't mean we would do this. Nobody's promising it, but I'm just pointing out that there are multiple plausible job creating opportunities here if we want to participate in this industry. Next slide, please. So with no plan, no solicitation for power, a couple of problems with that. The one that actually drives me the most, although I've been talking about industrial facilities and jobs and stuff, is that Delaware's not implementing a potential huge reduction in CO2 emissions. So one of these facilities would be about 28% of Delaware's electricity demand. And you're taking that off CO2. Yes, you create some CO2 in building the facilities and building the towers and so forth, but that pays itself back in the first year or two of operation. So after a year or two, you are eliminating almost 30% of Delaware's electric production CO2 emissions in one shot. Second thing is air pollution. We sometimes forget about that, but the electricity, which has some clean sources and increasing gradually through the RPS and other policies, but mostly when we use electricity, we're putting criteria pollutants into the atmosphere. So a single wind farm the size we're talking about would save about 18 lives per year. So that's also something we're not doing if we don't want to build these large-scale renewable energy facilities. And there's a potential of lowering prices, or at least not increasing them if the solicitation is done correctly. Take one example, Massachusetts, which had a much better solicitation than many states. They found over the life of the offshore wind project, which was the same size I'm talking about here, would save $1.4 billion saving to consumers. So everybody thinks renewable energy is more expensive. That's not necessarily true anymore. Wind and solar are often less expensive, and offshore wind has been more expensive than those two, but it's now getting to the point of cost competitiveness with existing fossil power. And as I've been talking about, if we're not participating in the market at all, we're not going to be part of this new industrial supply chain that's being built by our neighboring states, therefore pushing away employment and economic development opportunities. Next slide. So have questions at the end, I believe, but thanks for your attention, and thanks to the League for inviting me to participate. That's all. I have a slide on environmental impacts if somebody wants to ask. That's for later.
Okay, our next speaker is Chris Olaf, and she is currently the Director of Special Initiatives of Offshore Wind. And Chris comes to us with 15 years of industry experience in offshore wind. And since the days of the industry's inception in the US, she held senior positions with offshore wind developers, NGOs, and state agencies. She's gained critical insight into the policy and regulations that shape our offshore wind activities at the state, regional, and federal levels. Chris has extensive experience in working with offshore wind stakeholders and has expert knowledge of such engagements, having worked on offshore wind and ocean policy issues at all levels. She currently, as Director of Special Initiatives, leads the organization on to develop strategies to support the responsible and sustainable development of offshore wind industry. Originally from New Jersey, she is a Rutgers graduate, has a master's degree from the University of Rhode Island, and currently lives in Morris County, New Jersey with her husband and retired racing greyhounds, sorry. So Chris, take it away.
Thank you, Dick, and thanks to the League for having me today. Certainly appreciate it. I am somewhat of a newcomer to Delaware, so I appreciate the warm welcome that I've been getting from the League and others. And, speaking to you this morning, I couldn't help but think about the connection to the potential $3 trillion infrastructure bill that is now being discussed by the Biden administration. It will reportedly have two tenets, and one of those tenets will be around infrastructure and clean energy. So I think Delaware is really kind of coming into this conversation at the exact right time, because there's going to be some strong incentivization at the federal level. And I think really there's a tremendous opportunity for benefit. We've spent 30 years on the planet figuring out how to build offshore wind farms. We know how to do it more cheaply now. We know how to do it safely, and we know how to do it technically. So we can benefit in the US and in Delaware from the huge gains that have come from the learnings in other states and locations around the world. And I think that's, in 2017, there was a working group in the state of Delaware that determined there was more to learn. And I think a lot has been learned in these past several years. And we want to share a little bit about that today, and also the way the special initiative might be supportive of Delaware in next steps, as Peggy alluded earlier. So Dick, if you wouldn't mind moving to my first slide, or second slide, I guess, I can skip this one. Wanted to tell you a little bit about the special initiative on offshore wind. We are an independent project at the University of Delaware's College of Earth, Ocean, and Environment. And we support the advancement of offshore wind as part of a comprehensive solution to the most pressing energy problems facing the United States. Certainly, we read about these energy issues all the time and the way they're interacting with climate and our economy. And SIOW has been at the lead of developing strategies and assisting state and federal policymakers on how to advance the industry since 2013. So, really excited about this new era for offshore wind in the US. Willett mentioned all the lease areas that Delaware would have access to. So the real estate is there. Procurement opportunities could be on the horizon for Delaware, and the special initiative stands at the ready to be supportive of our home state. Even though we have kind of a national focus and work across the country, we are housed at the University of Delaware and independently funded. And so we have a strong affinity for the state, let's say. So if you could move to the next slide, please, Dick. Some of our publications, activities, and accomplishments are listed here on the slide. Akin to the potential study for Delaware would be the first two bullets on the slide, which are the New York and Massachusetts cost studies, where essentially the states commissioned the special initiative on offshore wind to take a look at what the cost would be for electricity if they issued certain parameters as part of that procurement process that Willett talked about. So those were kind of the initial studies that we did in both Massachusetts and New York. We did release in 2019 an industry seminal publication on supply chain contracting and the forecast that essentially indicated that there would be up to or in excess of $70 billion in revenue just from the capital expenditures of building out the supply chain on the East Coast of the US. Special Initiative was proud to share those data. It was the first time that look had been really done at the supply chain for the East Coast. We also have a history of multi-sectoral engagements and convenings. So when there are user issues, when there are groups who have user conflicts, we're able to bring those together from a neutral position, from a relatively independent position, in that we do not have a membership. We are not a trade organization. We do not count on membership dues or need to provide that type of accountability to anyone. We are doing the work that is scientific, analytic, and that's delivering the best data on the question. So we have been called to for these convenings and engagements in that relatively neutral and independent way. And we've also had the opportunity to create regional organizations like the one that we helped stand up in New York called the New York Offshore Wind Alliance, which is a multi-sectoral coalition of the people in New York who want to see offshore wind done right. So it's really a spectrum of developers, NGOs, and others who have a strong interest in New York, something to certainly consider for Delaware as well. The next slide, please. I want to talk a little bit about the economic and environmental benefits of offshore wind in these next couple of slides. And so, Dick, if you wouldn't mind going to the next slide, we'll talk about the environmental impacts first. Willett, I stole your slide here, so you don't need to show it later, but I added a North Atlantic right whale picture to it and wanted to emphasize that by far the biggest environmental impact of offshore wind is positive. Of course, we know that no projects, and I'll use a double negative here, don't have any impact, right? I mean, no matter what we do, walking out of the house each day has an impact on the environment. But if we're really looking to develop systems on how we can fight climate change, then we need large scale renewables. And offshore wind is the only marine renewable energy technology that's ready to be deployed at scale at this point. So certainly we appreciate the wave and tidal and other folks who are interested in marine renewables, but offshore wind is the only utility scale technology that is at its prime time. When you look at the potential impacts to birds and bats, you will see that in general, wind turbines kill or harm far fewer birds than many other types of infrastructure that's located currently on our planet, whether that's onshore or offshore, to the point where the Audubon Society has supported many offshore wind projects, knowing that really the biggest threat to avian species is reduction in habitat due to climate change. And so if you take offshore wind turbines and you put them further than 8 miles offshore, you'll see a precipitous drop in avian and bat species, because the birds want to be where there's habitat and food. And those things don't exist generally more than 8 miles from shore. So you take the turbines, you put them further offshore outside of flyways, and this enables groups to be supportive from an avian perspective of offshore wind. Now, this doesn't mean that developers, when they build the projects, won't need to go through and are going through very rigorous environmental reviews at both the state and federal levels. There are a variety of different permits that are needed, and it's all done under the auspices of the National Environmental Policy Act, for which each wind farm will have its own environmental impact statement. So really a lot of data, pre and post-construction monitoring, baseline studies are needed in order for developers to move forward. And that includes surveying of birds, existing data, and then sometimes collecting new data on that. It has been reported, that there could be impacts to sharks and rays, also known as elasmobranch species, in the ocean, because there is a very small level of electromagnetic fields that radiate from cables. Now, these submarine cables that connect wind farm to land, they're armored, they are insulated, and they are buried at least 6 feet underneath the seabed. This eliminates most of the EMF that's coming from the cables, but there have been studies that have shown slight attraction or repellent from these cables, depending on the species and the study. So it's important to understand what the impacts could be. It's important to weigh them. And it's important, I think, that as an industry, if we're going to have a sustainable industry in the long term, that we do this very responsibly. And so I really appreciate the League's efforts in understanding the truth about offshore wind and understanding that really on its merits, on the facts, offshore wind will win every time. As Willett mentioned, some people will say, oh, well, how can it be a climate friendly project when you have to have all these machines to build a project and build a port? All of those emissions are, they're already earned back within the first year or so of the operations of the project. So I think it's important that we think of the entire life cycle and all of the attributes that offshore wind carries with it. Finally, I'll just mention, not that it's certainly a very important topic, marine mammals and sea turtles. The marine mammal that's pictured here is a North Atlantic right whale, and there are only a few hundred of those North Atlantic right whales in its entire population at this point. So it's a critically endangered species in our region, and it migrates right off the coast of Delaware. So we have to be very sensitive, understanding mitigation measures, technologies, and ways that we can make sure that we're not harming the right whale population in doing something that, like building a wind farm or operating a wind farm, where we're trying to preserve the environment, right? So I think that can be done. It's been shown to be done in Europe, where you can use mitigation strategies during construction that minimize noise that could, for example, disrupt their feeding. Super important that those type of mitigation strategies are front of mind. So next slide, please. Some of the economic benefits of offshore wind really come through the creation of jobs, and not only the job creation of building the wind farm, and there are substantial jobs, several thousand jobs per utility scale wind farm that are created. Those jobs, however, are temporary. Really what comes, and Willett mentioned it earlier, is the construction and the operation of manufacturing facilities, ports, and vessels. And that is because of the supply chain and the, the pipeline of projects that are being proposed for the US, how we are drawing that supply chain development here, as was mentioned in the Port of Paulsboro. For example, in the state of South Carolina, there is a large submarine cable manufacturing facility that was located by a company called Nexans. That is a huge job creation for the state of South Carolina. And it is that type of supply chain. Right now, all the offshore wind turbines are built in Europe. We want to induce those manufacturers to come here by showing them strong support. And Delaware has the opportunity to be a part of that job creation and part of that supply chain. I mentioned the special initiative study in 2019 about the 70 billion in CapEx, but I also just wanted to mention that the American Wind Energy Association released a study last year that showed 83,000 jobs will be created by the year 2030. And that's only including the current state target. So Delaware could absolutely be additive to that. And we will see in the future, I believe, other states' goals rising as well. So 83,000 jobs. I mean, you're looking at a once in a generation opportunity for a new marine infrastructure and all the jobs supported by that. So it's a really exciting opportunity for the nation and for the state. Next slide, please. I won't go deeply into this. Will talked about it earlier, but really we're seeing all this on the back of the fact that the cost of electricity from offshore wind is precipitously dropping. What I will call your attention to on this slide is if you see the Massachusetts and New York numbers on the cost of electricity, on the costs per kilowatt hour, you're seeing the lowest numbers on those lines. And that's because partially, I mean, we'll take some credit for it. The special initiative did those studies, those cost studies that advised the states on how to get to those costs, those low costs. And that is what we can also do for Delaware. Understand the trade-offs and figure out how we can bring those costs, those low costs of electricity to Delaware. Right now, Delawareans are paying, just over 7 cents per kilowatt hour on average. And so you're seeing, the offshore wind really coming in at that sweet spot. So not only would you be able to pay the same, perhaps lower or similar cost of electricity, but bring all of the environmental and economic benefits that come with it. Next slide, please, Dick. And why is this lower cost of electricity now? Why is this here at this time? It's really because of the technology development, including the larger turbines. When you have a larger turbine, you need fewer turbines to meet your capacity target. Therefore, you have fewer foundations to build, fewer turbines themselves. So those capital expenditures drop pretty rapidly. So that helps drop costs. In Europe, we see specialized vessels and handling really making many advancements over those 30 years and figuring a lot out for us. So we're learning a lot from our European compatriots. And then in the US, we see this project pipeline that would be assuring to companies of the supply chain investments they're making. So at the Port of Paulsboro, those monopiles by that German company EEW, that's kind of that's a textbook example. You see a German manufacturing company who have been manufacturing monopiles around the world for offshore wind for decades. Now they're locating in New Jersey because New Jersey said, hey, we have a nice procurement pipeline for you. Why don't you locate here and provide monopiles for the region? And so New Jersey benefits, in a very significant way from that new manufacturing base. And I mentioned about SIOW's contribution in New York and Massachusetts. So Dick, next slide, please. And just finally, my last slide to mention the opportunity here for an offshore wind study for Delaware as a next step. The goal would be to model the future cost of electricity of an offshore wind procurement for the state. And we could look at the cost impacts of including economic development incentives. For example, what tends to happen is if a state requires a strong level of workforce, in-state workforce or in-state infrastructure development, that can slightly bring up the cost of electricity because the developer needs to meet more stringent restrictions and they end up, rolling that into the price of their bid for power. So sometimes it's a sliding scale. It's not an absolute, but it's, you know, how much in-state job creation do we want to require versus how much do we value a lower cost of electricity, and how much would the state be willing to bear on either of those issues. And at SIOW in this report, the idea is we could model what that would look like based on those, you know, those parameters or desires. There are a variety of financial mechanisms we could look at, including a power purchase agreement, also known as a PPA for short, or an offshore renewable energy certificate, OREC. So we could evaluate what different procurement types we might need, the different size options, as Willett was referring to earlier, the REC options, renewable energy certificate options, and really a whole variety of factors. These are just some scoping options that we've thought about. Professor Kempton at the University of Delaware, he's also our technical advisor here at SIOW. He would lead that study. We would need about 6 months to do that. And really the next action item on this is a resolution, a concurrent resolution by the Delaware legislature indicating serious interest in such a study. And so we have been having preliminary conversations. Peggy knows much more about this than anyone, but that is at SIOW. The next step for us is we are waiting to hear about the strong interest that the legislature would have in such a study. Now, keep in mind, this would not obligate the state to do anything. This would not cost the state anything. That is the study, because the SIOW would take that on, and we are independently and philanthropically funded, so it would not cost the state anything. And in fact, this is one of the recommendations, indeed, of the 2017 working group, is to understand more about some of these parameters. So we are offering this to the state of Delaware. We hope that this happens as a next step, and we look forward to the continued conversation. So Dick and Peggy, thanks again.
Thank you, Chris. That was very informative. And we look forward to hopefully doing this study at some point. So my next speaker is Dr. David Bidwell. He's an associate professor at the University of Rhode Island Department of Marine Affairs, and he uses the theory and methods of environmental sociology and social psychology to understand the environmental decision-making. David has published extensively on the public attitudes and experience with offshore wind energy development in the United States. He holds a PhD in sociology from Michigan State University and an MS in natural resource policy from the University of Michigan. Prior to joining the facility at the University of Rhode Island, David served as a manager of Climate Adaptation Research Center, a public participation consultant, and an environmental educator. So, David, happy to have you here and anxious to hear about the social impact of offshore wind.
Well, good morning, everybody, and thank you all for inviting me to be part of this. I interestingly was just driving through Delaware a couple of days ago, but also it holds a certain I hold a certain fondness for Delaware in that I used to live in Philadelphia and spent a lot of time going down to Bombay Hook for bird watching, at least a couple of times a year to go down there. So you can move forward to the first slide. Excellent. So I am here, I'm in the Department of Marine Affairs at the University of Rhode Island. Marine Affairs is a small multidisciplinary department that deals with all kinds of management and policy issues for marine and coastal issues. I came here about 7 years ago, and one of the reasons that I was brought on board is because of an interest in looking at the social aspects of offshore renewable energy. And that's what I spend most of my research time working on. So you can move forward to the next slide. This is one of the reasons that I spend a lot of my time working on this. This is the Block Island Wind Farm. And this is what we're going to spend my time talking about, is this this project, some of the ways that it is like and not like the kinds of projects that Willett and Chris were talking about, and talking about some of the ways that the communities in Rhode Island have responded both to the plans and construction of this wind farm, and some of the impacts that they have felt from it now that it is fully operational. Next slide. So why do we worry about the social aspects of offshore wind farm? Many of you may be familiar with the Cape Wind project. This was a project that was proposed that would have sat between Martha's Vineyard and Cape Cod in Massachusetts. And it was proposed in the early 2000s and really went through a couple decades of public opposition, lawsuits. Eventually, it missed some important milestones for its power purchase agreements. Those were pulled out. And in 2017, the developers basically gave up their lease to this area, and this project is now defunct. But there is certainly a whole, there's a whole study and sort of dialogue around the social aspects in offshore wind development, and a broad acknowledgement that there's a lot of knowledge and expertise around the technical aspects of putting wind farms in the water, but that the social aspects are just as important as those technical aspects if you want to get these kinds of projects completed. Next slide. So we are fortunate here in Rhode Island that we have this laboratory that we can use to try to understand the interactions between our coastal communities and the project. This is a picture that I took from just below the bluffs on Block Island on the south coast of Block Island. Now, this is looks very different, and I'll explain why in just a minute, than what things would look like from the coast of Delaware. These are much larger in the view than the kinds of projects that are being proposed in federal waters. The project at Block Island is within state waters, which makes it actually quite close to the island. But what this has provided for us is an opportunity to really understand these interactions between people and the turbines in the wind farm. So next slide. Just to get you a little bit of a sense of where we are, this is Block Island. So you can see Cape Cod hooking out there into the island, Nantucket and Martha's Vineyard right below that. Over towards the left, that big island coming out is Long Island with the point of Montauk sort of pointing straight out there towards Block Island, and where it sits about 9 miles off the coast of Rhode Island, with Point Judith being the closest point. So next slide. This is what the project looks like. This has been referred to sometimes as a pilot project or a demonstration project, but it is the first functional offshore wind farm in United States waters. What you see are these 5 turbines. They are 6 megawatt turbines, so they are smaller than what some of the pictures are that Willett was showing you, but they are still quite large, about 600 feet above the surface of the water. And those 5 turbines are connected by an underwater cable that is buried in the sediments and goes into a substation on Block Island, where it does power the island itself. The island used to be powered by diesel generators, but no more, in part because of the wind farm. But then also the excess power, which is, by the way, most of the power that is generated by the turbines, is sent through another underwater cable buried in the sediments that goes ashore at Scarborough State Beach in Narragansett, and then is integrated into the broader grid within Rhode Island. That cable also provides the first physical connection of the island to the mainland, so that if the turbines are not spinning, if they're down for maintenance or there's no wind, the island is now drawing its power from the broader grid from Rhode Island. Okay, next slide. So this is an important point for the Block Island Wind Farm. It's actually constructed within state waters, so just inside that 3-mile limit of what is designated as state waters. So a lot of the relationships that we see in Block Island make it what's sometimes called a near shore wind farm, in that it is actually very, very close to the shore of Block Island. And so that affects some of the things that we're going to look at in terms of the social impacts. But in terms of the mainland to Rhode Island, we're looking at the turbines being roughly 16 miles off that main coastline there of Rhode Island at Point Judith. And so that makes it more analogous to the kinds of distances that we're talking about for most of these projects that are planned in federal waters. Okay, next slide. So as I mentioned, we've been able to use this as a laboratory. I see there's a little bit of formatting issues around some of the slides. We've been able to do a lot of different studies here in Rhode Island and in cooperation with some other folks in other universities, certainly the University of Delaware. Many of you may know Jeremy Firestone. You see his name there as well. Looking at different dynamics around public support, attitudes, on trying to understand public participation, tourism and recreation impacts, recreational fishing impacts, etc. And so we've been able to publish a lot of these articles in academic journals, but we really look for these opportunities as well to share some of the things that we found with the broader public. I'm going to try to not be super academic in the way that I present these things and really just stick to some of the key points. All right, next slide. So this is, first, I want to give you a little bit of understanding of some of the data that we collected around the time that the project was being completed. This is a picture created by the original developer, Deepwater Wind, in 2016, as the final turbine blades were just being put out. Okay, next slide. Some of the things that we've done involve collecting public opinions. You can see on the left, this is one of my students from a few years ago, actually out at the visitor center where the ferry drops people off on Block Island collecting data. And then on the other side, you see a map of some of the areas where we did mail surveys actually to households, both on Block Island and in coastal Rhode Island. And this was a project that Dr. Jeremy Firestone from the University of Delaware was kind enough to ask me to collaborate with him on, and I'll show you some of the results from that as well. Okay, next slide. So the first few slides that I'm going to show you are from that study of people on Block Island itself. And this is a combination of people who live there full time, visitors who are visiting the island, and seasonal residents as well. And this is just asking them what they anticipated the impacts of the wind farm would be. This is before construction actually began. And what you can see here is that everything that kind of goes to the right are anticipations of positive benefits, positive impacts. Things that swing to the left are things that people by and large thought might be negative impacts of the wind farm. So next slide. And what we see is that by and large, people were fairly positive about the impacts to socioeconomics and some of the things that affect people, jobs, costs of electricity, environmental health, human health, quality of life, etc. But they were much less optimistic about the potential impacts of the projects on some of those resources around fishing, boating, wildlife, natural character of the ocean, and scenic views. And you might see some of these trends through some of the other things as well. Next slide. One of the things that I'm particularly interested in is the relationship among different variables and how that leads to different attitudes for support. And so this project looked at both sort of underlying values that people hold, how that influences their beliefs about the ocean, how that influences their beliefs about the wind farm or anticipated impacts of the wind farm, and how that relates to support overall. Next slide. And what we see are some fair consistencies in some other research that I've done onshore with wind farms, which is that support for the wind farm is most influenced, at least in my research, about what people anticipate those impacts will be. If you think that the wind farm is going to have positive impacts on resources and socioeconomics, you tend to support the wind farm more. However, there are some underlying beliefs that influence those anticipated impacts. So if you believe that the ocean is primarily for consumption and creation of commerce, you tend to be more supportive of the wind farm. If you're more concerned about what I call ecological cultural beliefs, which are things about the ocean being a place for wild animals and history and culture, then you're less supportive of the wind farm. And the same thing when we get back to some of these foundational values. If you are more concerned about the welfare of others and you look beyond yourself in terms of trying to see benefits to society and to other people, again, tend to be more supportive of the wind farm. If you have more traditional, or sometimes what are called more conservative values, where you are really valuing the current order of things, security, familiarity, those kinds of values tend to be less supportive of the wind farm. Okay, next slide. So these are some results. Don't worry about all of the numbers swirling around. I'm going to point out the things that I think are most important from this slide. This is from those surveys of households that I did with Dr. Firestone at the University of Delaware. And what you see is actually a fairly high level of support. This shows both support before the wind farm was installed and then support after it was installed. What you see on Block Island itself is not a whole lot of change between before and after. You get, 70% of the people who have a strong support. When you combine that in with people who are leaning towards support, you end up with this 80, 85%, which is pretty standard when you ask people about their support for a renewable energy project. What we do see, however, on the mainland, where you are, 16 miles from the planned project, was a real change between pre-installation attitudes and post-installation attitudes, where sometimes we characterize this as a not as bad as we thought response, where people were hesitant in their support before installation, but after installation, you see more people moving towards this higher levels of support for the project. Okay, next slide. We wanted to try to understand some of the reasons behind these attitudes, and what we see is that among people who supported the project, you see a lot of people characterizing the project as being symbolic of progress towards clean energy. You do see some people who oppose the project who also understand that. But in terms of people who oppose the project, what you see is a real concern about the visibility of the project and losing that sort of intangible wildness of just seeing the ocean. You see concerns about the project being industrial and really detracting from the island and coastal character. And what we find when we do this and we look at some broader analyses is that concern about the appearance of the project and how it fits in or doesn't fit into the seascape has a lot of influence over whether people support the project or not. So the visibility and the appearance of the wind farm and how people interpret that visibility in terms of fitting into the landscape or not really does make a difference in terms of support. Okay, next slide. So another aspect that I'm particularly interested in, I used to work as a consultant in public participation projects. And what we see in doing some research around public participation for the development of the Block Island wind farm is that there was a real separation in terms of people's experience with something that was called the Ocean Special Area Management Plan. And this was a multi-party 2-year process trying to understand the potential impacts and how people viewed them, that was conducted largely here at the University of Rhode Island at the request of our Coastal Resources Management Council. And that had a very different sort of feel than the permitting process itself, when the developer was going out and trying to build support for the project along actually getting the state and federal permits to do the project. A couple other things that we found that were really important with participation is just the importance of informal relationships. Yes, it is important to have big public meetings and hearings as you go through this process, but really it was very important for the developer to get out in the community, listen to people, communicate to people, and really develop that strong relationship. One of the ways that this developer, Deepwater Wind, achieved that was through hiring these local liaisons. So they had a community member on the island of Block Island who was there to answer questions, communicate with residents, etc. And people really credit that as an important piece. We developed in this an idea of something we call chains of trust, which is that the public really has to have trust in the process leaders before they can trust the process and trust the outcomes and accept those outcomes. Next slide. I worried about this with the formatting, so we'll just ignore that. Go ahead to the next slide as well, and I'll just talk about this. In a follow-up project that I did with Jeremy and some of his students, what we found is that some support for this idea of the chain of trust, people's level of trust in the state, in particular in state government, really influenced how they felt about the process and the outcomes. If they felt that the state was just trying to ram the project through, they had less trust in the process. If they felt that the state was being a legitimate and trustworthy player, then they were more accepting of that process. We also found, however, that people sort of reserved their judgment of the process until they actually saw the outcome. So for some people, they looked at the project after it was built, they said, that's not so bad. That created more trust in the process sort of in the past. So there may be a little bit of inversion in terms of cause and effect sometimes when we look at people's feelings about the process. All right, next slide. So one of the main concerns here in Rhode Island, and I'm sure you have heard this, I know you've heard it from people in Maryland, but you've probably heard it from people in Delaware as well, is what will be the impacts of the wind farm on tourism and recreation. So we did spend some time on this. Next slide. Sponsored by the Bureau of Ocean Energy Management, which is the federal agency that looks at the leasing and permitting of wind farms. They sponsored us here at the University of Rhode Island for a 2-year project trying to understand the tourism impacts of the Block Island wind farm on the island itself, but also on the mainland. Now, one of the things that we found out was that we had done a poor job of developing some baseline information in terms of quantitative information that makes it really difficult to understand the quantitative impacts of the project. So if you're going to do a project and you're concerned about tourism and recreation, get that baseline information in place early on. But this was primarily a qualitative look at how the wind farm had affected tourism and recreation. So some of the things that we found out, tourists and recreationists are really a diverse group. We tend to talk about them as their one thing, but that is not at all the truth. We have people coming from out of state who are spending a couple of weeks here. We have people from nearby states that are making a lot of day trips. And we have people from Rhode Island itself who are spending time on the coast as part of their quality of life of living in the state. What we heard overall were by and large neutral to positive responses to the project. In fact, when we talked to some people on the mainland, they couldn't even quite understand what we were asking them, like, why would the project that's 16 miles offshore have any impact on tourism and recreation on the mainland? So we did hear that from some people who ran restaurants or tourism businesses, et cetera. We did find that the wind farm is acting as an attractant for some people. They want to be near the wind farm. They want to see it. They want to understand of it. Sometimes we think of this as sort of like nerd tourism. If you think about whether you took your kids to see dams and bridges and buildings when you went on your vacations, this has some of the same effects of people wanting to see it and sort of understand it. We did find that the people that we talked to had some nuanced responses. So they're kind of doing their own sort of cost benefit analysis. They might say, well, I don't really like the way they look, but if it's providing clean power for the state, then I guess it's okay. Or vice versa. They might say, well, you know, I really think they're cool looking and I think they're interesting, but I understand how some people who visit might not like it. Okay. I see someone just asked why no pictures from Point Judith. It's mostly about my poor lack of ability in taking pictures. Also, it depends on the day. Some days they're actually just not visible at all from Point Judith. The ocean has a lot of different weather conditions and haze, and so some days you can't see them at all. Some days they are fairly clear. But no, I don't have pictures from Point Judith in this. The other thing that we found that I think is important is we like to say there's no tabula rasa. We tend to think of tourists as being sort of this blank slate. They're going to come, they're going to see the wind farm, and then they're going to decide whether they like them or not. That's really not what we found out. People come in with preconceived notions of how they feel about offshore wind or industrialization of the ocean, how they felt about the process used to develop them, if they were people or visitors from Rhode Island. If they didn't like the process, they didn't like the way the turbines looked. If they did like the process, they were more accepting of them on the beaches. So people are filtering their response through their earlier experiences. Okay, next slide. I know I'm using a lot of time. Let me try to do this quickly. We've also had a project that was sponsored by Rhode Island Sea Grant, looking at the impacts of the wind farm on recreational angling. As you can see from this map from the Special Area Management Plan, this was an area and is an area which is used for recreational fishing fairly heavily. So we did a project that involved both interviews and survey work. In the interviews, we found sort of three primary findings, which is fishermen are using the wind turbines as a new enhanced fishing spot. And that's for a couple different reasons. One is the perception that the fishing is good around the base of the turbines, but also they're a big stick coming out of the water, so they're easy to navigate to, and they create a destination where people enjoy looking at the turbines in addition to fishing around them. Because fishing isn't just about catching fish, it's also about the experience of being out on the water. Overall, we found that the anglers were optimistic about wind farms, about both the Block Island wind farm and future developments, but they have some reservations as well. Next slide. Here you can see some of the reservations. This is from our surveying of some of the anglers that are there. And what you can see here is towards the left that people have a much more cautious feeling about the effect of the wind farms on things like natural beauty, navigational safety, boat traffic. There is some concerns about crowding and more traffic around the turbines as people are attracted to that area, concerns that that might exert more pressure on the fish in the area and the ecology of the area. However, when you ask people questions about fishing habitat, the fishing experience, more trophy fish, more diversity of the fish, people are more optimistic about that in terms of how they look at it. Here you can see also a little bit of a difference between the blue line, which is all of our anglers together, and then that middle line, which are people who had actually fished at the turbines in a boat where they had to navigate around the turbines, and people in the green line, which were people who had never fished at the wind farm itself. And you can see that the people who fished at the wind farms were actually more optimistic than the people who hadn't. So there was something about either the nature of those fishermen that attracted them to the turbines, or something about their experience at the turbines themselves that made them feel more optimistic. Okay, next slide. At this point, ignore this slide because you can't see what the numbers mean. But overall, this is just my message that we tend to think of fishermen or other kinds of recreational or tourists as being interested in only one thing, okay? But they're not. Fishermen are also people, and tourists are also people. So one of the things that we found is that, does fishing at the wind farm and an impression that the wind farm improves fishing, does that relate to people's support for the wind farm? It absolutely does. If you've fished there, if you think that the fishing is good and that the wind farm is good for fish, that improves your support for the wind farm, but not as much as some other factors. So if you think that the wind farm is symbolic of clean energy, or you like the way the wind farm looks, that is going to increase your support for the wind farm even more than having a good experience of fishing there does. Okay, next slide. So we know quite a bit about how people are interacting with the wind farm, but there's still a lot of things that we don't know. There are some differences between the Block Island wind farm. It's small, it's only 5 turbines. It's actually relatively close to the island. So there are some things that make it very different than what the larger wind farms in federal waters are likely to be in terms of how people experience them. There are also some impacts that are hard to study, and we're trying to do these. So this shows a commercial fisherman fishing in the same area around the wind farm. And some of you have probably heard there is a great deal of opposition within the commercial fishing industry. And we're still trying to understand that and understand those dynamics that are there. So we're still likely, even though a lot of people have been very positive about the Block Island wind farm, we're still likely to see sources of opposition to this additional development of wind farms in federal waters. And so I'm going to say, let's go ahead and stop there. I had a couple more slides, but they sort of repeat some of the things that Chris and Willett talk about. And now we can get into some of the questions and the discussions. So thank you.
Thank you, David. That was very insightful and good questions. So let's start with some of the earlier questions here. One directed to Willett, the BOEM lease areas, are those areas currently not being used, or are some of them already being used?
Well, there's no, other than the wind farm David was just talking about and 2 units off Virginia, there's no running turbines. So those, the Virginia is a BOEM lease. The Block Island one, as David mentioned, is state waters. So that's not a BOEM area. So all of those areas, amazingly enough, are kind of ready to go. And in some cases, you know, the orders are all set up. I mean, they're just waiting to get the final okay from the permitting people in the federal government in BOEM. But others are just not even called on. I mean, there's a developer who has rights, but there's no project. So there's plenty of open ocean space that's been designated for projects, which are not dedicated to any project yet, although somebody has rights to build there. And they will sell rights to each other and so forth like that, or do alliances. But there's plenty of space. I think maybe the sense of the question is there any space for a Delaware project? And the answer to that is yes. There's at least 3 nearby spaces that would be plenty for a Delaware project to be built.
The other question is, what is a induced job, and what do you mean by marshaling port?
That's also for me, it sounds like. Okay,
Yeah,
so
it does
a
sound-
direct job is taking that operations and maintenance port. Direct job is you go in and you get your marching orders for the day, and you get on the boat with your toolkit, and you go out and you do preventive maintenance. That's a direct job. Also, the person who operates the radio, the person who cleans the floors. Those are all direct jobs. Then there's the Snap-on tool people who come out and sell tools to those folks. That's an induced job. Maybe Snap-on needs to hire an extra 1 or 2 people. There's somebody who sells breakfast before they go out. Those are all induced jobs. They're not directly working for the O&M port, but those jobs would not be there if it weren't for that operation. The other question is, what's a marshaling port? If you think of the word marshaling in the military sense, you marshal your army. You get the people, you get the tanks, the weapons, you're ready to go, gear up, and then you go out. So marshaling port, you're getting parts from these factories. You're getting blades from one place, then the cells, so that big thing I showed a picture of, those are coming from another place. Maybe the monopiles I mentioned, would be made in New Jersey. So those get ready to go. They might go to the marshaling port also. And so then when you see, okay, I've got all the parts I need, and I've got the contract for the boat to do the installation, then you say, okay, we're ready to start. We can do 10 turbines over the next 2 weeks. So that the boat comes to the marshaling port and it loads everything up at once. The boat is very expensive, $150,000 per day. Day rate for the vessel. It loads up, then it goes out and builds the actual turbines at sea, comes back to the marshaling port, loads up again. So that's what the marshaling port is. It's a key piece of the whole picture.
So the other question is how did the SIOW end up at the University of Delaware, and who are the independent funders for that project?
The independent funders are currently primarily the Rockefeller Brothers Foundation, and that is through their sustainable development program. They have been interested in seeing the responsible and sustainable development of offshore wind since 2013, when they worked to help bring SIOW to inception. And Willett, maybe since I wasn't around, I've only been on for a few months, maybe you can provide a little more anecdotal story about how we ended up at the University of Delaware.
Yeah, so this was not my doing. This was Stephanie McClellan, who I happened to be married to, but she was looking for an administrative home. She had talked with Rockefeller Brothers. They had a plan to create something like this, and they thought about independent operation, a sort of a part-time accountant and a few things like that. It just made more sense to affiliate with an academic unit. There was a lot of offshore wind expertise already at the University of Delaware. The dean of the College of Earth, Ocean, and Environment was amenable and supportive. And so there's all the kind of machinery of a institute or a research operation or an outreach operation already there, and it was synergistic. So that's kind of short history, I guess, of it.
Okay, this goes out to any of the speakers. I get lots of anti-offshore literature that shows pictures of the wind turbines very visible from the beach. What is an accurate picture of a visual of the wind turbines from the beach?
I'm happy to jump in on that first. There's one of the largest projects being developed off the coast of southern New Jersey now. It's called the Ocean Wind Project by my former company, Ørsted. And that project, if you go to oceanwind.com and you scroll down, there are technically accurate photo simulations developed of what the wind farm will look like from shore. A common way to think about it is if you think of a small stack of pennies on the horizon, or maybe if your outstretched arm was looking at your thumbnail, that is approximately the height of a turbine of that size and magnitude, about 15 to 20 miles offshore. But I invite you to check out oceanwind.com for very accurate representations of that project, and which is relatively representative of an industrial scale project these days.
And let me jump in too, since we have the project here, it's so variable with the weather. There are days where they are not visible at all. And then there are some days where there's almost like that effect on the ocean where things just sort of pop and you can really see them. There's actually, just anecdotally, we've heard from some people, they're now using the turbines as a proxy for how nice the weather is. It was so clear that you could see the turbines from Wisconsin, it really, there's this sense of, you can see them some days and some days you can't. I have seen them from lots of different vantage points. So there are lots of different places that you can see them, but I've also had days where I was trying to point them out to people and they just couldn't see them. So in part, it's going to depend on how many turbines are at a certain distance and what the visibility is on different days. So it's highly, highly variable.
Thank you. The other question is, since the SIOW for Delaware, the study isn't costing the state anything, why can't they just do the study, and why do we need a resolution?
Well, we have pretty limited resources in that SIOW is essentially me and Willett with some of his busy time. So though we will have technical assistance from support at the university, we want to make sure that our limited resources would be respected and that there is interest in the state in receiving such a study. So a resolution that just says the study will be considered and, essentially, accepted by the state as something that's, worth reading is all we're asking. So a strong indication that it would be valued.
So an add-on to that question is, what can we do to encourage proposed study for the Delaware to the state legislature? That probably ties in together.
I'm not a Delaware person, so I leave that to Willett or Peggy to expand upon.
Yeah, I defer to Peggy on that.
Yeah, we'd really like to encourage our listeners to contact their legislators to let them know that a concurrent resolution in support of an SIOW study would be a great thing to do at this time. There's a pretty long time frame for getting an offshore wind project up and running. So we do need to have data before we ask people to seriously consider this, and this is such a credible way to get the data. And so if you guys could all contact your legislators, everybody's got a representative and everybody's got a senator that go to Dover. So if you could contact each of those folks and tell them that you'd really like to see a concurrent resolution, that would be terribly helpful for those of us who are working on the front lines lobbying, because we need your backup.
Thank you, Peggy, for that. Another question is, what is the potential impact on the Delaware wind farm from projected sea level rise? Would this have an impact on the large capital expense to place and maintain the turbines?
I'll just give a quick answer. That would be part of the design.
Yeah,
all of these things that we can think about sitting here have been thought about in other projects and will be thought about in a future project. It might mean they add, a foot or two to the height of the platform that you access the turbines, for example. But that will definitely be in all of the calculations and design engineering.
Someone like nerd tourism. That was a good move, David. We'll all remember nerd tourism from this speech. This one's kind of a delicate question, but I'll throw it out. I'm asking this politely since you will be asked by others. Do any of you have financial conflicts of interest as you are evaluating the OSW projects?
I do not.
Okay.
I don't either. I would, as Chris said, I think she's going to delegate me to do the study. I don't benefit from more wind farms getting built. I care a lot about climate change, and this is a big chunk that you can do at a time to reduce CO2 emissions and criteria pollutants. I care about that a lot, but that's not considered a conflict of interest. And in doing a report, I'm not going to say we have to do this because it's good for the environment. That's a professional analytical job. You know, it costs this much, creates some jobs, or it doesn't create jobs, and it creates this much reduction in pollution. There's not a, by UD's very strict criteria for conflict of interest, I do not have any conflicts of interest in doing a study like this.
Here's a question about windmills. So everybody's
Can I-
heard that the
Dick,
wind.
Can I?
Oh, go ahead. Sorry,
And real
David.
quick on I just want to make a point on the conflict of interest thing. So I don't have any conflicts of interest either. The University of Rhode Island did get a commitment from Ørsted for money for research that was part of their agreement with the state for one of the contracts that they bid out. And I want to encourage people too in Delaware, as you're thinking about messages to legislators, I think it's actually a really important one to add in there, that there should be benefits to the state that are specifically laid out in agreements between the state and developers, whether that's specifically for communities, but I also feel like there's a lot of money out there, right? And so the developers need to actually be anteing up money for these kinds of studies and the kinds of work that is going on at the universities. And that's something that the public can clamor for from these agreements with developers as well.
And just to add on to that, David, maybe, I don't know if you were on when we talked about this earlier, but one thing we just want to be careful about is how that increased the cost of electricity for projects, because that all gets baked into the bid number. So it's something I think we just want to be thoughtful about, and an SIOW study could look at that range of options.
Actually, this is a great debate among the three of us. So totally agree with what you just said, David. But in doing a study of how to do contracts, how to do bids, we would have to have 10-foot distance from any developers or anyone with any interest. Otherwise, the study is not going to be perceived as legitimate. It's going to be perceived as having a conflict of interest, and it could have a conflict of interest. So there would be no support from any developers on this. And as Chris already said, the operation is funded by by philanthropy that's trying to get sustainable development, not from anybody who benefits from wind projects. So there's a kind of before and after effect. And maybe if something gets built, maybe the university benefits. It's not really going to benefit me personally or SIOW directly, but university could benefit more research or something like what you're talking about. That's by UD rules, that's not considered a conflict of interest on a study.
All right, I have the last question. So, and this is a couple people have asked this. So I've heard that the windmill blades do not last forever and that they cannot be recycled efficiently, which everyone's heard that, but no one has a solution. Is there a solution?
Yeah, so in Denmark, there is recycling of wind turbine blades on a prototype basis, and not every wind turbine blade that's discarded. There's some have gone into landfills. There's several research projects on recycling wind turbine blades. And can you grind them up and then make more wind turbine blades, or do you make some other plastic product that doesn't have the same strength requirements? I mean, all that stuff is getting worked out now. UD's Composite Center has a big project on trying to figure out how to recycle wind turbine blades. So this is an active area. It's not a solved problem yet, so that's correct. Whereas all the steel and copper and everything else, you just melt down and you make other things. But wind turbine blades are an active area of research right now. And that's not just offshore, that's any wind turbine blade.
And I would just add to that, Will, that the good thing is an operational wind farm will last about 25 to 30 years. So we have some lead time on this issue, and I'm confident that's something we can get to resolution on by then.
Well, I want to thank all the speakers today. It's been very informative. And David, it's nice that you flew in from Rhode Island today, and Willett in Philadelphia, and Chris. So I'm going to turn it over to Peggy to have closing remarks here. You're on mute.
We're so grateful to all of you, to our amazing panelists, and to our wonderful Dick Johnson. Thank you, attentive and engaged in audience, for your great questions. It's time to say goodbye now, but before we sign off, we want to encourage members of the audience to contact their legislators and please ask for a concurrent resolution supporting a scientific study by the SIOW on options related to an offshore wind project for Delaware. And I've put that information in the chat box. So thank you all.